This guy here is the same thing except in reverse. So what you're going to do, once again, it's a KSP problem. So you've got to set it up so that it is PbOH2 breaks into Pb plus 2 and 2 OH negatives. You don't have a choice in the matter if you want to deal with KSP. KSP is going to then be equal to the lead times the hydroxide squared. And I've got an I, I got a C, and I got an E, and I don't care about any of this. Now, I didn't say about starting with any of these things, but it does say that we have a saturated solution. So once again, that's code for at equilibrium. And it's telling us that I have a pH of 913. So basically, in this problem, what we're going to do is instead of starting here, we are going to start at our pH square, where I have H positive times OH negative and pH and POH. They're starting me here because they gave me a pH of 913 in a saturated solution. And what I'm then really interested in getting is this guy here, which I can then use to plug in here for my OH negative that's there, all right? So they told me that this is 913. So I'm going to then turn that into a POH. So 14 minus a 913 gets me a 487. 487 negative, and then 10 to the gets me a value of 1.35 times 10 to the negative fifth. Again, if you'd prefer, you could go around the other way. You can go with 9.13 negative and make this 7.41 times 10 to the negative 10th, and then take 1 times 10 to the negative 14th divided by 741 times 10 to the negative 10th, and get our value here of 135 times 10 to the negative fifth. Doesn't matter. Okay, so now this is this. 135 times 10 to the negative fifth. Now I know what you're thinking, but Smith, there's a 2 there. Shouldn't you double it? No, because it's telling me what it is. It's telling me that this is the value because it told me what the pH was. So I'm not going to double that one, but I am going to recognize that there is a 2-to-1 ratio here. So if that is 135, then this one here has to be the 135 cut in half. So this has to be 675 times 10 to the negative sixth because of that 2-to-1 ratio that's here. So you are correct that you have to deal with the half, the fact that this is a 1 and the other one is a 2. But they told you figured out what the orange one is here, and so then you can figure out that the other one has to be half as much. So now what you do is you take these guys here and you plug them into your equation there. So this is going to be 135 times 10 to the negative fifth, and I'm going to square it, and then I'm going to multiply that by 675 times 10 to the negative sixth, and I should then get a KSP value in the neighborhood of about 1.23 times 10 to the negative 15th. That is there. Because again, these numbers here get plugged in. That one gets plugged in there. The orange one gets plugged in there and has to be squared. And then we're in good shape.